Hi everyone, this presentation is about the Python implementation of a stack using lists, specifically designed for the HKDSE syllabus. A stack is a data structure, where the first element that goes in is the last one that comes out. Alternatively, you can say that the last element that goes in is the first one that comes out. There are mainly two functions associated with a stack. The first is called push, which means adding an element to the stack. The second is called pop, which means removing an element from the stack and returning the popped element for further use. For example, we want to push an element into the stack S. The two diagrams shown on the right are examples that may appear on your exam paper. The left diagram is a stack representation, while the right diagram is an array. This is what appears after adding a second element B to the stack, S. Next, we pop an element from the stack and store the element in a variable called temp. Finally, we push an element C onto the stack, and this is the final diagram. Now we are going to implement a simple version of the push operation. It works with just one specific stack that is defined in the main program. When we push an element, we must first ensure that the stack still has space for it. Otherwise, a stack overflow error will occur. We will now translate the English text into Python code highlighted in green. The push function is shown on the left, the test code is displayed in the middle, and the test results are shown on the right. Next, we will implement the pop operation. It's the opposite of the push function. Instead of checking whether the stack is full, we check if it is empty. If we attempt to pop from an empty stack, the stack underflow error will occur. Again, the code is shown in green. In this case, although resetting the element in the stack to null does not affect its behavior, it is a good practice to reset it for security purposes or to reduce potential bugs when incorporating other functions in the future. The pop function is shown on the left, the test code is displayed in the middle, and the test results are shown on the right. Now we move on to a generic version of the push function. It works with multiple stacks. Instead of just taking one parameter, now we take two parameters. The first one indicates which stack we will add the element to. Furthermore, instead of using a variable n to keep check of the stack size, we use the codes highlighted in green to calculate the current stack size. The generic push function is shown on the left. Instead of hard-coding the size as 4, we use the length function to determine the size of the list. Subtracting it from the count null function will yield the size of the occupied stack. Finally, the generic version of the pop function is shown on the left. Note that it is important to reset the popped element in the stack. Otherwise, the count null function will not work properly, and the occupied stack size will be incorrect.